What is up, YouTube, and welcome to episode 82. We're 82 now, yeah? Yeah, 82. So yeah, let's get into it. New scales arrived. So we're going to jump down quickly and reweigh all of these so we can get proper numbers. I've checked them with my calibration weights. They are very accurate. They go between 500 grams and 0.01 grams. They do 100th of a gram, so we should get nice accurate numbers on how much these actually weigh. Not that it really matters, because we have decided that going with that tessellated pattern that I chose is actually suitable. So it's just for peace of mind. It's for my OCD. I want to know how much they really weigh. So let's get into it. All right, let's get started. Let's go through this nice and quick. First up is the 2mm thickness. That came in at 77 grams. Actual number is 78.45. 1mm shell, 44.85. 0.75mm shell, 36.25. This is the straight ribs. Came in at 27 grams. 26.6. 27.2. And that was 28, so not bad. That's a nice improvement. Let's put it on here, 27.2. Some more straight ribs, 28.3. The crosshatch, 26. Wider spacing across hatch, 28 on the dot. So that was accurate. These are the ISO grids, 32.85. And this is the tighter ISO grid, 38.5. The helical lattice structure was 33, is 32, and our latest one came in at 28, 28.45. So they were actually quite close. So that leaves me scratching my head then, because if we look at some of these that should be heavier, right? For instance, these crosshatch ones, there's more material in this one. So why is it lighter than this one that has less material in it? And something leads me to believe it has something to do with the interaction. You see where it's a bit darker? This could be excess resin, or resin and alcohol from the washing process that doesn't get washed out properly and gets trapped. And if you compare it to this one, you can still see there's still, like, it's not a straight line here where it should be. It's a bit wavy. So there's areas where the two faces, there's resin being trapped in between the two faces, and it's not getting washed out properly. So that could be it. Same thing for in the corners, any of the corners anywhere. Yeah, I'm not too sure how this one that should be lighter is heavier. It really doesn't make any sense. Same for this one here, right? There are physically more ribs. The ribs are the same thickness, and this weighs more. Like, why is this one lighter? I don't know. Anyways, it doesn't matter because we've switched to using the lattice structures. But now we know. So it wasn't the scales. There's something else funky going on that I can't identify. Is it worth going through the effort of trying to identify those issues? Probably not. So we will leave it as is. But we now have definitive numbers on those weights. So it wasn't the scales. It was indeed something else funky going on that we're just going to ignore because it doesn't matter. Because this is all we care about, is this strong, lightweight structure. Just for shits and giggles, I have the new parts that we printed, the wingtips, and these ones that will be reprinted because I need to get more carbon fiber structure in it. But I want to weigh these just for shits and giggles. So these wingtips come in at 14 grams. And that one's just a little bit lighter. So yeah, not bad. And these sections, 31 grams. So they're more than double the length. There's easily more material if you go by the taper and stuff. So yeah, I'm seeing a good scalar in the weight versus the size of the object. So when we print, say for instance, the wing root, which is going to be quite a large section, it's going to be a big boxy piece, that should come in at about 30-35 grams going by these numbers. Quite a bit of weight inside this section here with this thickness, as well as this spar that runs through here. So yeah, we'll leave it there for today's episode. Super short. I'm not going to bother. There's not much going on. Printer's down. I'm waiting for post and stuff. Working on CAD. I'm working on compliant mechanisms. I'm playing with that. I've got this itch. I've got this itch to make a morphing wing geometry. It's going to be sort of, I'm not going to design it for something to fly as yet. There's a lot for me to learn still about in the subject, but it's mostly just playing around with the different materials that I have available, like tenacious and stuff like that. So I'm thinking of designing a multi-material wing that is all epoxied together and becomes one structure, but sections of it are made with different material properties, and then you can insert servos and stuff in there with pressure points and hinges and pivots and all that sort of stuff, and you get a wing that sort of changes its shape depending on where the servos are applying pressure and stuff. So yeah, that's a lot of fun. It's not working quite as well as I wanted at the moment, but it's still early days. I'm using Inventor's FEA, it's material simulations tool to actually do this, which is quite handy because I can just select a soft material and go apply a force here, and then it will show me kind of how the material is going to deform before I even print it, so I can, you know, avoid wasting material on a design that doesn't work or behave the way I want it to. So yeah, we'll leave the episode there for today. Thanks for watching. Make sure you hit the like button, make sure you subscribe if you're not. Go check out my other channel, there's nothing there but just subscribe so I know that you're interested. And yeah, as always, I've been Chaos, and until next time, expect the unexpected, and I will see you guys later.
And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.